After looking at maximum areas and volumes, we need to take another look at maximum length. And we need to determine the maximum length of MN. Now you should remember we do cover this concept in Form 4, so just let's have a look at what we did last year. If we want the maximum distance between two graphs, we go top graph minus bottom graph. And in this sketch, M is on touching the parabola, which is on the top. So we list our parabola first, minus the straight line. If we distribute that negative, we end up with minus x squared minus 2x plus 8 minus 2x minus 8, which we can simplify to minus x squared minus 4x. Now it's a very good idea to write mn on the left-hand side all the time. It might stop you from dividing by a negative or making it equal to 0. Remember, we're not allowed to do anything to this equation. At this point, we now need to have a look at what we're really trying to determine. We're trying to determine the distance of mn. Now that equation represents all these little distances between the two graphs, indicated by red on the sketch. Now let's just take them down and put them on a straight line, just to get a better idea of what we're looking at. If I look at them on a straight line, I end up with quite short distances that get longer and longer, but then they get shorter and shorter as they move towards the y-axis on the original sketch. Now, do you notice anything about those distances? Well, if I add a curve to them, it looks something like a parabola. And that is the equation that you've got. So mn is equal to minus x squared minus 4x is actually the equation of that parabola, the parabola formed by all the distances. And we're looking for the distance that is the longest. And that appears to be this one in the middle. And where do you think that is? Well, it looks like the turning point. And how do we find the turning point of the parabola? Using minus b over 2a. So in this equation, b is minus 4 and a is minus 1. So we end up with minus 4 over 2 times minus 1, which I can simplify to minus 2. So that tells me where the maximum length will take place, not what the maximum length is. So to find the maximum length, we will put minus 2 back into the equation. So we get minus 2 squared minus 4 times minus 2, which gives me an answer of 4. So the maximum distance mn can be is 4 units. Let's take another look. In example 2, we are going to calculate the minimum distance of PQ, which is the distance between a hyperbola and a straight line. Now our method is going to be exactly the same if we want to calculate minimum distance or maximum distance. We still use the equation top minus bottom. So the distance PQ will be the top graph minus the bottom graph. And in this sketch, the top graph will be the hyperbola, which is 4 over x plus 1, minus the bottom graph, which is the straight line, minus x plus 1. If we distribute the minus, we end up with 4 over x plus 1 plus x minus 1, which we can simplify to 4 over x plus x. But now we have a problem. We cannot use the equation minus b over 2a to calculate that x value. We have to make another plan. But why did we choose to use minus b over 2a? We were trying to calculate the turning point of our new equation. Is there another way we can calculate turning point? Well, using calculus, we can make the first derivative equal to 0. So in my equation, if I want to make the first derivative equal to 0, I first need to prepare my equation because I can't use any fractions. So I'm going to rewrite it as 4x to the power of minus 1 plus x. The first derivative, then we use our rules. So we'll take the exponent down to the front, making it minus 4x to the power of minus 2, and the derivative of x is 1. Before we carry on, I just want to talk about the notation quickly. We had PQ on the left-hand side, and usually we have a y on the left-hand side. So if you want the derivative of y, it's just dy over dx. But now we've got PQ on the left, so we can just write it as dpq on the top. Then the value on the right, or the variable on the right, is an x, so we write dx on the bottom. If you prefer, you can rewrite PQ equals as y equals and then just go dy over dx. But this notation is very easy to use. We're now going to make the equation equal to 0 and solve it further. So first thing I want to take over is my 1 and it becomes negative. So minus 1 is equal to minus 4 over x squared. And we need to solve the equation. So we're going to multiply by x squared. So we end up with minus x squared equals minus 4. Divide by a negative. And now to solve that equation, we can either take the 4 over and do difference of 2 squares, or we can just square root it. Now remember, if we're square rooting, we have a squared, so we have to have plus and minus on the right-hand side. So we end up with x is plus or minus 2. But if you go back to the original question, we are looking for the x value that's greater than 0, so we're only going to use x is equal to 2. And I need to substitute that back into my equation for PQ. So PQ will equal 4 over 2 plus 2, which can simplify to 4. So the minimum distance of PQ in this example is 4 units. Let's just go back to example 1 and see if this method will give us the same answer. Now remember, we got a maximum distance of 4 units. So the process starts in exactly the same way. To get the distance mn, we go top minus bottom, so parabola on top minus the straight line underneath, and we simplify to minus x squared minus 4x. So you can choose to use minus b over 2a, or you can choose to make the first derivative equal to 0. Now the first derivative will be minus 2x minus 4, and just have a look at the notation. We had mn on the left, so we've got dmn on the top, x on the right, so we've got dx on the bottom. If we make it equal to 0, I can take my 2x across to the other side and divide by 2. So my maximum distance will occur where x is minus 2. If we substitute it back into the distance mn, we end up with minus 4 plus 8, and I end up with my maximum distance of 4 units. So if you have a parabola and a straight line, you have two methods. You can either use minus b over 2a, or you can use the first derivative equal to 0. Unfortunately, if you've got a hyperbola and a straight line, you will have to make the first derivative equal to 0 in order to determine the minimum or maximum distance. Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.